Yeah, I guess it's time to start Chapter 3, Section 3, and that is Dividing Polynomials, and later we'll get into the remainder and factor theorems. And in this video, in the first day in class, we're just going to do long division of polynomials. And then after I torture you with that, I'll show you the quick and easy synthetic division method. And tomorrow we'll also talk about the remainder theorem and the factor theorem to help solve a polynomial equation. The first part of this is usually the most painful, polynomial long division. And hopefully, if you have seen the division algorithm like this with just regular numbers, I know if you've gone through the everyday math program, maybe you did not see this division. What we got here is the number 3,521, and we're dividing it by 16. So how many times does 16 go into that number evenly, or is there remainder after we do it? Now here is the way I learned it oh so long ago. I want to divide 16 into this number, so first do I check, does 16 divide into 3? No, it doesn't. So I start looking at the first two numbers, 35. Does 16 go into 35 how many times without going over? Well, it goes in twice, so I'm going to put the 2 up top. 2 times 16 is 32. And then here we always subtract. 35 minus 32 is 3. And we bring down the next term in the number 2. Okay, does 16 go into 32 how many times without going over? Well, it goes in, and let's even make this a little more interesting. Let me change that to a 3. We'll make that a 3. So we bring down the next term 3. How many times does 16 go into 33 without going over? Again, twice. 16 times 2 is 32, and we subtract 1, and then we bring down the next term 1. How many times and how many more times will 16 go into that? Well, none. You know, one time is more than enough. So 0. And then 0 times 16 is 0. We subtract one more time, and we get 11. 11 is less than 16, so that's our remainder. And we would write it as a fraction. Remainder, 11 is the numerator. Denominator is our divisor, 16. 11 sixteenths. So how many times does 16 go into this number? 220 times, with 11 sixteenths left over. Or another way to think about it is 16 times 220 and 11 sixteenths is equal to 3521. So this factor times this factor is equal to the whole thing. We just sort of broke it apart. We found 3,521 divided by 16 was 220 and 11 sixteenths. I could say what is 3,521 divided by 220 and 11 sixteenths, and that would equal 16. All right, and that's just concrete with real numbers. We're going to do something very similar with polynomials. We begin by looking at division by a polynomial containing more than one term, such as x plus 3 is going to be divided into x squared plus 10x plus 21. The divisor here has two terms. It's a binomial. The polynomial dividend has three terms, and it's a trinomial. When a divisor has more than one term, the steps used to divide whole numbers, divide, multiply, subtract, and bring down the next term, form the repetitive procedure for this polynomial long division. All right, let's try it out. And this is the one we just saw on the previous page. We're going to divide this trinomial by this binomial. So let's write it out. X squared plus 10x plus 21. And we are going to divide that by the binomial x plus 3. I like to just say concentrate on these leading terms. Leading term of the binomial is an x, and for now our leading term here is x squared. We can think about this two ways. The book thinks about it as a division problem. What is x squared divided by x? Well, x squared divided by x, we would subtract the exponents and get x to the first. I like to think about it this way. I need some number up here. I'll put a question mark. Some number times this x is exactly equal to x squared. What times x is x squared? Well, just like the division showed us, it is x. So here I multiply, sort of like we are distributing. This is a quantity, and I'm going to multiply x times it. X times x is x squared. And then x times the 3 is 3x. And here we subtract. X squared minus x squared is nothing, and that's what we always want to have happen here. And then 10x minus 3x is 7x. Bring down the next term, 21. Again, just concentrate on the leading terms. Here is a 7x. Something times x is 7x. Well, it's got to be a 7. 7 times x is 7x, and 7 times 3 is 21. And when we subtract, 7x minus 7x is nothing. 21 minus 21 is nothing. So we have no remainder. There's nothing left over. And our answer is this x plus 7. Now, if I was to do this, let's see here, 24 divided by 6 is equal to 4 with no remainder. Another way to look at this would be to multiply both sides by this denominator 6. 24 is equal to 4 times 6. And we could do that here with this polynomial and say that x plus 3 times x plus 7 is equal to x squared plus 10x plus 21. Again, if I multiply this, x plus 7, times the x plus 3, those are two factors. If I multiply them together, I get this whole thing. Just as how I multiplied the factors 4 and 6 together and got 24. Same idea going on here. It's always nice when there's no remainder. Here's our 6 steps for the long division of polynomials. 1. Arrange the terms of both the dividend and the divisor in descending powers of any variable. So look at your variables. The exponent should be going downhill. Divide the first term in the dividend by the first term in the divisor. The result is the first term of the quotient. So that's here x squared divided by this x gives us the first term of the quotient x. Multiply every term in the divisor by the first term in the quotient. Write the resulting product beneath the dividend where the like terms are lined up. You know, here again, I erased it, but down here we had x squared and then some term x. We line them up so our powers are in the same columns. Step 4, subtract the product from the dividend. Again, we are always subtracting here. That's an easy place to make a sign error. Step 5, bring down the next term of the original dividend and write it next to the remainder to form a new dividend. Use this new expression as the dividend and repeat the process until the remainder can no longer be divided. This will occur when the degree of the remainder, the highest exponent on a variable in the remainder, is less than the degree of the divisor. In 6 easy steps to divide our polynomials. Okay, let's try this one. Now I see first off that my powers are out of order. We're dividing this 4-termer by the binomial. So I'm going to first write this in descending order. 6x cubed goes first, and then we got an x squared term, and then we got our minus 5x term, and then our plus 4. And we are going to divide that by the binomial 3x minus 2. Again, our first term of our up here is going to be either you can take 6x cubed, the first term here, and divide it by 3x. Well, 6 divided by 3 is 2. X cubed over x is x squared, 2x squared. Or some number up here times 3x is going to equal 6x cubed. We'll just think numbers first. What times 3 is 6? Well, that's a 2. What times x is x cubed? Well, that's got to be an x squared. And we multiply. 2x squared times 3x is 6x cubed. And then 2x squared times minus 2x is minus 4x squared. And then at this point, remember, we always subtract. And again, this is a great, great place to make a sign error. 6x cubed minus 6x cubed is nothing. Minus x squared minus a negative 4x squared. Sort of add the opposite. Imagine this is a plus. And then that would take us to 3x squared minus, and then we bring down the next term, minus 5x. Okay, again, we need something up here. Times 3x equals 3x squared. Well, 1 times 3 is 3. And then x times x is x squared. So here we go. Multiply this x times this binomial. X times 3x is 3x squared. X times minus 2 is minus 2x. Again, here we are subtracting. So we are going to minus 3x squared minus 3x squared is nothing. Negative 5x minus a negative 2x, that would turn this into a plus. And then we can just add, that'll be minus 3x. And then we bring down our next term, the plus 4. All right, last one. Something up here times 3x is minus 3x. Well, that'll have to be a minus 1. Minus 1 times 3x is minus 3x. And the minus 1 times the minus 2 is plus 2. And again, here we are subtracting. Subtract the first terms, there's nothing. 4 minus 2 is 2. Now notice there's no more terms to bring down. So this is our remainder. What do we do with the remainder? Well, we can make it into a fraction. The remainder that we found is our numerator, and it's a positive 2, so we're going to have a plus 2 over. Our denominator is this divisor, 3x minus 2. So over 3x minus 2. And let me double check that with my work I have in my notes, and that looks good. Again, you know, what is this saying? This is saying if we multiply our divisor, 3x minus 2, times what we found up here, our answer, the quotient, oops, and I forgot this, times 2x squared plus x minus 1. And then we could put this sort of outside the plus 2 without the denominator. If we were to FOIL this out and then add in the plus 2, we're going to get right back to where we started. Or again, here's another way to think about it. When the problem started, it was 6x cubed minus x squared minus 5x plus 4 divided by 3x minus 2. And we found out that that was equal to 2x squared plus x minus 1 plus the 2 over 3x minus 2. Okay, if I take this and multiply both sides by this denominator, you know, over on this side, I'm going to have 3x minus 2 times this term. I'm not going to rewrite the whole thing, and that's equal to 6x cubed minus x squared minus 5x plus 4. So again, if I brought this term down here and FOILed it all out, the sides of the equals, or the equation, will be balanced. It'll be the same on each side of the equals sign. All right, one last thing to go over here. Okay, one more example after we talk about this division algorithm. So here we have the official book definition of our division algorithm. If f of x and d of x are polynomials, and d of x is not equal to 0, and the degree of that d of x is less than or equal to that of f of x, then there exist unique polynomials, q of x and r of x, such that f of x is equal to d of x times q of x plus r of x, the remainder. The remainder r of x equals 0, or its degree is less than the degree of d of x. If the r of x does equal 0, we say that d of x divides evenly into that function f of x, and that d of x and q of x are factors of f of x. Again, that's quite a mouthful, and it's hard sometimes to wrap your head around that with all this function notation, f of x, d of x, q of x, r of x. If I back up here, trying to find a way to tie that in with what we had in that last example. In the last example, and let me write this out here again, f of x equals d of x times q of x plus r of x. From our last example, you know, if you check with your notes here, I'm just going to do our divisor was that 3x minus 2. What we were dividing that by was the bigger one. We had to rearrange in descending order. 6x cubed minus x squared minus 5x, and I'll squeeze in that plus 4 real small. This divided by this, we had that our quotient that we found there was 2x squared plus x minus 1, and then plus our remainder there was 2. You know, here's that division algorithm with the example 2 polynomials stuck in there. Again, here's what we started with. That polynomial was equal to our divisor times the quotient we found plus the remainder. This division algorithm says, you know, that that's always going to be true. We can take some polynomial and divide it by another polynomial, and we'll get our answer, our quotient, maybe with plus or minus a remainder. And this will work for all polynomials. Now here's a biggie, and I put a little star in here. I need you to write something in your notes, and that would be, and actually here, instead of me writing it, since I have this fancy software, I can just type it in there. Okay, if a power of x is missing, add that missing power with a coefficient, with a coefficient of 0. This applies to the dividend or divisor. So we always got to have all powers of x accounted for. If we look here in example 3, we have 6x to the 4th plus 5x cubed plus 3x minus 5 divided by this. Let's check our powers. We got a fourth power. We got a third power. Oh, first power. We're missing a squared term. We do want to account for that. So as I'm writing this out, I'm going to have my 6x to the 4th first plus 5x cubed. Now we're missing a power. We need a 0x squared to hold its place. And then we continue with our plus 3x and our minus 5. All right, now if this was 3x squared minus 2, we would want to add in a plus 0x because we want every power accounted for in our dividend or our divisor. But we do have every power accounted for here. That's just 3x squared minus 2x. We don't need to put a plus 0 constant. All right, let's see if we can divide this bad boy. I need something up here times 3x squared is going to equal 6x to the 4th. Well, let's just start with the numbers. A number times 2 equals 6. Well, that's got to be a 2. X to some power times x squared is going to equal x to the 4th. Well, that's going to have to be an x squared. And we put that right over our x squared term in the dividend. 2x squared times 3x squared is 6x to the 4th. And I also multiplied 2x squared times minus 2x, minus 4x to the 3rd. Again, we are subtracting. If you want to think here, we could, make this into minus this quantity, and then you could distribute your negative. So we could make this a minus and then change this to a plus, and now we add. If we add here, we get nothing. And if we add up, we get 9x cubed. And then bring down the next term, plus 0x squared. Okay, we need something up here. Times 3x squared is going to equal 9x cubed. Well, what number? What times 3 is 9? It's got to be a 3. What times x squared is x cubed? It's got to be an x. Multiply. 3x times 3x squared is a 9x cubed, and that better work every time because that's how we set it up. And then we have a 3x times a minus 2x is minus 6x squared. And remember, here again, we are subtracting a quantity, and we could distribute that and add. So we can distribute here, now it's a minus. Distribute to the minus, now it's a plus. And now we can add, and those will go to 0. And we'll get a 6x squared. Bring down the next term, 3x. All right, some number times 3x squared is 6x squared. Well, 2 times 3 is 6, so that's got to be a plus 2. And what times x squared is x squared? Well, that's going to be nothing. We're going to leave it alone. All right, 2 times 3x squared is 6x squared. 2 times minus 2x is minus 4x. Again, we are subtracting, so this will turn into minus a negative or plus, and then that'll be 7x. Bring down the next term, minus 5. All right, that's our remainder. Now, down here, our highest power is a 1, and our highest power up here is a squared, so this has to be our remainder. And also, there's no more terms to bring down. So it's going to be a plus the quantity 7x minus 5 over 3x squared minus 2x. And there we go. Again, what we've also found is this times this plus the remainder is equal to this. Alrighty, you've listened to me enough. Here are 3 for you to try, these parallel examples 1, 2, and 3. So pause the video and give those a try and see how you did. Okay, let's see what we got here in the first one. I need something up here. Times x is going to equal x squared. Well, it's got to be x. X times x is x squared plus x times 9 is 9x. Subtract. 14x minus 9x is 5x. And bring down the constant 45. Well, something times x is 5x. It's got to be a 5. 5 times x is 5x. 5 times 9 is 45. 0 remainder. So now we have 2 factors, and what another way to look at this is x plus 5 times x plus 9. If I FOIL this out, I get x times x is x squared. My outers are 9x, my inners are 5x, that adds up to 14x. And then my last term times last term, 9 times 5 is 45. And that's exactly what we started with up here. All right. Next one had to be rearranged in proper order, but every power of x was accounted for. So something up here times x is 2x cubed. Or 2x cubed divided by x is what? 2x squared. 2x, that's a terrible 2. 2x squared times x is 2x cubed. And then 2x squared times minus 3 is minus 6x squared. And we subtract, so this will be add the opposite, and we'll get a 3x squared. Bring down the minus 11x. What times x is 3x squared? It's got to be 3x. 3x times x is 3x squared. And then 3x times minus 3 is minus 9x. We are subtracting, add the opposite, minus 2x, bring down the plus 7. Okay, what times x is minus 2x? It's got to be negative 2. Negative 2 times x is minus 2x, and then minus 2 times minus 3 is plus 6. Subtract, remainder is 1. So that remainder becomes our numerator, 1 over x minus 3. Let's try this out sort of like we did the last one. It's always neat to see how this does work out. So if I multiply x minus 3 times 2x squared plus 3x minus 2, and then I add in the remainder, I should get back to this. So let's see. X times 2x squared is 2x cubed. X times 3x is plus 3x squared. X times minus 2 is minus 2x. And then minus 3 times 2x squared is minus 6x squared. Minus 3 times here is minus 9x. Minus 3 times minus 6 is plus 6. And don't forget the plus 1. I'm sort of going to bring that down here and put it on the end. So if we add all this up, we'll have our 2x cubed. Add this x squared terms, we get a minus 3x squared. These two x's add up to a minus 11x. And then this 6 and 1, well, I just bring down the 6. That 6 plus 1 turns into this 7. And then everything matches up. 2x cubed, 2x cubed, minus 3x squared, minus 11x. There we go. Checkpoint 3, we had to add plus 0x squared because we were missing the x squared term here. Our divisor has all powers of x accounted for. So don't forget to make sure you have every power of x. When I was in school, I always did this in my head. When I got it all set up, I'd do this like a little jump. 4, 3, 2, 1, and you got them all. All right. We'll think about it this way. What is 2x to the 4th divided by x squared? Well, the 2 would stay, and x to the 4th over x squared is x squared. 2x squared. So 2x squared, I put it right over the other squared term. 2x squared times x squared is 2x to the 4th. And then 2x squared times minus 2x is minus 4x cubed. And we subtract. So when we subtract a negative, that'll turn into a plus. 7x cubed, bring down the 0x squared, the next term. Something times x squared is 7x cubed. It's got to be 7x. So we multiply and get our 7x cubed, and then 7 times minus 2x is minus 14x squared. So we subtract, adding the opposite. Now it's 14x squared, and we bring down the 7x. What times x squared is 14x squared? It's got to be 14. So we multiply there and get the 14x squared we need. And 14 times minus 2x is minus 28x. Again, we subtract, add the opposite, so that turns into a 21x. Bring down the next term, minus 10. Our power here, squared, is higher than our power here, so we're done. We have our remainder, 21x minus 10, and that's divided by the divisor, x squared minus 2x. Again, if you want to check your work, you could multiply this times this, FOIL it out, collect your like terms, and then add in the 21x minus 10, and you should get back to where you started. For your amusement at home, page 373, 1, 3, 4, 5, 6, 7, and 13. Look to make sure all powers are accounted for.